Okay, 16 through 20 in this video. So let's see, what's the domain of the function of this function here? Well, what are the possible problems it could have? What are things that we would not be allowed to plug in? On the bottom, we can't have the bottom of this be equal to 0. You're not allowed to divide by 0. The only thing that makes that equal to 0 is 3. So because of the bottom here, we can't have 3 be part of the domain. And then on the top, we can't have what's underneath the square root sign be negative. So I need to make sure that x squared minus 4 is greater than or equal to, it could be equal to 0, right? 0 divided by something, that's fine. And that gives me x squared has got to be greater than or equal to 4, and like other discussions we've had in other problems, if you've watched any of those videos, then that means that x is greater than or equal to 2, or x is less than or equal to negative 2. I need to think about that for a minute, why that has to be true. And 3 would be included, so it looks like we have to have a special case for that. So it looks like E is the correct answer. We want, oh wait, hold on, no. Sorry, we want this, right? We need the absolute value. So we need the absolute value of x to be greater than or equal to 2, and we need x to be not equal to 3, right? Absolute value of x greater than or equal to 2 is the same as this. All right. How about this? We might need to remember some natural log rules here. So natural log of x minus natural log of 1 over x equals 2, then x must equal. Remember, you can consolidate logarithms by multiplication here. So we could say, well, this is like division, right? So that's the same as natural log x over 1 over x is equal to 2. And if you flip that, do a little algebra, that's actually an x squared. So that says natural log of x squared is equal to 2. So that gives me x squared is equal to e squared. So x is equal to e. So C is the correct answer. And you could check that really quickly. The natural log of e, of course, is 1, and the natural log of 1 over e is negative 1, so 1 minus negative 1 is in fact 2. So, happy days. And 18, if f of x is equal to x over x plus 1, then the inverse function, remember how to find inverse functions? I'm going to give myself a little bit of room here to do the algebra. While I'm setting that up, I could offer you the possibility. Of course, you could try a number and see, just sort of guess and check it. I'll show you how to do that in a second if you're not sure what that means. But I'm going to do it algebraically. To find the inverse of a function, we swap x's for y's. That's what inverses do. And then we solve for the new y. So to do that, I'm going to bring that up over here and go ahead and distribute, because I like to skip steps. How about you? And then I'm going to get all the y's onto one side. I'm going to factor the y out. I've found in my experience that this little multiplying and then getting all the y terms on one side and factoring out, this is a sort of trick, if you want, or procedure that a lot of you folks tend to forget. So we take a minute to make sure you understand what happened there. And hopefully one of those, yep, there it is. C is the right answer. Now let me show you what I mean about guessing and checking. You could, say, take a number like 2. Well, what's f of 2? F of 2 would be 2/3. So one of these, if f of 2, if 2 gets turned into 2/3, then whichever one of these is the inverse function would have to take 2/3 and turn it into 2, right? It would have to invert it. So I can go plugging 2/3 into these and see which one gives me 2. So 2/3 minus 1 over, that gives me a negative number, so that can't be right. 2/3 plugged in here. 2/3 plus 1 is 5/3 divided by 2. 5/3 divided by 2 is 5/6. No, that's not right. We'll skip that one for a minute. And then here, 2/3 divided by 5/3 is 6/5, right? That's not right. 2/3, this would just turn back into 2/3. That's not right. So let's go back to the one we know is right. 2/3 over 1 minus 2/3, which would be 1/3. 2/3 over 1/3 is, right, that's 2. So that's the one that gets us back to where we started. That's what an inverse function does. Which of the following does not have a period of pi? Let's see. We know the period of this, it's 2 pi divided by whatever number's in there. Oh, that's 4 pi. Remember, that slows it down? So I guess that's the one that doesn't. We could go through the rest of these. Hey, how come this has a period of pi? Well, because remember, throwing absolute values around something, instead of this going down here, all the bumps would be the same, right? They'd all be positive, I should say, and that means it has a period of pi as those bumps repeat every pi. The squaring function that has a similar effect, all these positive values would get squared. It changes the shape of the bump slightly, but all the negative stuff gets squared just as the positive stuff would be, and it ends up having that period of pi too. Tangent, we know the tangent function has a period of pi, and tangent squared, I challenge you to imagine what that would look like, considering that all those negative bits would get squared and flipped up. So, correct answer is A. And number 20. Aha. Looking at the answers here, sometimes looking at the answers can inspire you as to what direction you should be going in. Maybe that would help you think about or help you identify. What you need to remember here is the cosine angle sum formula, that the cosine of A plus B is equal to the cosine of A times the cosine of B minus the sine of A times the sine of B. You remember that? It's one of those trig identities. You know, there aren't, I know you did a lot with that last year. There are a couple that come up. Probably the single most common one that comes up is the sine double angle formula. But sine and cosine angle sum and angle difference are good to know. Here, this one, you can turn it into the cosine angle difference formula by flipping the signs there. So the reason this is upside down is to indicate that plus goes with minus here, and vice versa. All right, so let's see if we can do that. I'm just going to factor my 4 all the way out to the front. So this is my A, and this is like my B here. So let's see. So that's the cosine of the first one times the cosine of pi over 3. So pi over 3, this is all something that happens visually in your, right, that's here, and that's the x-coordinate here. That's the short one. That would be, so the sine of it would be square root of 3 over 2, so that's 1/2. So that gives me that minus the sine of x times the sine of pi over 3. And then distributing the 4, I would get 2 cosine x minus 2 squares, 2 square roots of 3 times sine x. And that looks like B. So that's fun, don't you think?